In this video, I will demonstrate the microscale experiment of electrolysis of dilute sodium chloride solution. First of all, we have a dilute sodium chloride solution. Next, we have a specially designed dropper with a shorter and curved tip. Now, try to fill up the dropper with the solution as much as you can. After that, prepare two notice board pins. These pins will be used as the electrodes. Insert the pins into the dropper. When inserting the pins, make sure that the pins do not pierce both sides of the dropper. Also, make sure the pins are covered by the solution. And lastly, make sure the pins are separated far apart from each other. Prepare a petri dish. Fill up the petri dish with detergent solution to 2/3 of its volume. Make sure the tip of the dropper is submerged under the detergent solution. Prepare a power supply and set it to 9 volts. Connect the power supply to the pins. It doesn't matter which one is which. In this case, the red pin is selected to be the positive electrode and the black pin is selected to be the negative electrode. Switch on the power supply. Gas bubbles are given off at the negative electrode. Do you know which gas is given off at the negative electrode? The gases produced at the electrodes pass through the dropper and they are introduced into the detergent solution. The gases produced at the electrodes are trapped inside these bubbles. Place a burning spleen next to the bubbles and see what happens. A pop sound is given off. What does it tell us about the gas inside the bubbles? Hence, what does it tell us about the gas produced at the electrodes? The first question is, when we are loading up the dropper with the solution, we try to get as much solution as we can. What is the purpose behind this? When you are performing the burning spleen test, you may notice that the first few bubbles doesn't give you any pop sound. Do you know why? As the reaction proceeds, we observe that there are some dirty green jelly-like precipitate formed in the solution. What is this precipitate and how is it formed? Examine the two pins. What is the color difference between the tip of the two pins? And why we have such a color difference? Also, if you leave the setup to stand in air for half an hour or so, this is how it looks like. What is the brown solid and how does it formed? It is not a good idea to set up the apparatus like this. Can you tell me why this is inappropriate? If we repeat the experiment using concentrated sodium chloride solution instead, what would be the difference in observation? Do we still expect to have a pop sound in a burning spleen test? Finally, What is the advantages of carrying out an experiment in a microscale rather than a traditional scale? Can you suggest 3 advantages of microscale experiments over traditional scales? This is the end of the experiment.